Greetings. It is an honor to speak with you about a topic I believe is critical to our land, our people, and our future: the value of geography and GIS education. This photo I took of the arrow moving forward reflects where we've been, but also encourages us to move forward in this critical hour. Why use location as a framework for study? Every issue in our communities, our state, our country, and in our world in the 21st century is geographic in nature. It's geographic in nature, whether it is energy, water, population change, equity, economics, supply chain management, natural hazards, or any of the UN Sustainable Development Goals, or SDGs. They all occur somewhere and display patterns, relationships, and trends that we can study, understand, and solve. What is geography? Geography provides the foundational skills and perspectives for such analysis. Geography is not memorizing state capitals or imports and exports of countries. Rather, geography is analyzing change over space and across time. It is about local to global issues. It is thinking holistically as systems. The biosphere is connected to the hydrosphere, the atmosphere, the lithosphere, and the anthroposphere, the human sphere. It investigates how humans affect the environment and how the environment provides for and affects humans. To give you more specifics, 3 geographic questions are as follows. What is the pattern of tornadoes across the USA by month and by year, by time of day? Which regions have been most impacted and why? Number 2, what impact will the continued low birth rate have on the future economic systems and the economies of Italy and Greece? Number 3, how has the decline in groundwater levels in the Ogallala Aquifer encouraged the economies of the high Great Plains to diversify? What are maps? Maps are not just reference documents. Where is Oklahoma? Where is the nearest coffee shop? Where is the Indian Ocean? Maps are analytical tools used every day in industry, government, nonprofit organizations to make smart decisions in planning transit routes, a location for a new business or health service, water and utility lines, next year's cropland, and much more. For centuries, and again in our digital age, maps have long been one of the most often used tools on Earth. They are on our phones, they're in our cars, they're on our watches, they're on our computers. In education, students not only use maps, but they create multimedia maps as they study geography. Yes, but also computer science, language arts, history, economics, biology, and other subjects. Maps are not reality, but they are representations of reality. Maps can be used to argue, to explain, to inspire. Today's maps can be made by anyone, including parents, students, the general public, which has great implications for data quality, but it also provides rich teachable moments for students as they learn how to communicate with today's dynamic interactive web maps. Speaking of which, this presentation that I'm giving today is using Esri's ArcGIS Story Maps tool, using techniques that faculty and students can use in the classroom. Indeed, mapping and geographic analysis gives students superpowers, as this tessellation map created by students shows of demographic characteristics of neighborhoods. These maps, tools, and data enable students to gain analytical and presentation skills, oral, graphics, written, in high demand in today's workplaces, for their career and to empower positive change. Today's dynamic web maps are also practical, tied to real people, real places, and real issues. Who is a leader here? I submit that you are all leaders, and I salute you for caring about this topic and especially about our students. These students are your future workers who will be a force for positive change. Now, why should you listen to me? I'm so passionate about geography that I have 3 degrees in it. and have the perspective of someone serving as geographer in these federal agencies, as an instructor in these universities, in nonprofit organizations, and for ESRI on their education team. ESRI, Environmental Systems Research Institute, is the world's largest creator of Geographic Information Systems, or GIS, tools. Our education team exists solely to serve you all in schools, colleges, and universities. I personally visited numerous campuses in Oklahoma face-to-face over the last 30 years and salute them all. Despite all this, I'm still learning, and I look forward to our future conversations. Let me cut to the heart of the matter. What do you care about? What do you want to see in society? At no time in history have we been so empowered, but yet we feel so challenged, don't we? That is why GIS exists. In 2004, the U.S. Department of Labor said there are 3 much-needed growth fields: biotechnologies, nanotechnologies, and geotechnologies. The geotechnologies, which are anchored firmly in today's discussion, includes Geographic Information Systems, or GIS, remote sensing, looking at the world from imagery generated from aircraft, satellites, or drones or UAVs, GPS, or more broadly global navigation satellite systems, and web mapping. These are tools, data, and methods that help us enable a more resilient, equitable, and sustainable world. A GIS is a computer system for creating, managing, analyzing, and displaying data on a map. GIS connects data to a map and integrating location data with all types of descriptive information. GIS helps users understand patterns, relationships, and geographic context, making connections more clear and new solutions possible. Why is GIS relevant to education and society? Students using GIS are not just learning about hazards, about climate, or about population change. They are examining these issues using professional software that a hazard analyst, a climate scientist, a demographer, respectively, actually uses day-to-day on the job. This software is free to schools and runs online on phones, tablets, and laptops with no installation required. It is used by the Jane Goodall Elephant Foundation, the Nature Conservancy, the Oklahoma DNR, and thousands of other organizations, truly a technology for good. Now, why talk about this now? Well, look, we face some pretty challenging issues in our society, pretty severe challenges. Many of the variables are heading in the wrong direction. GIS is behind all science, as well as business, engineering, and social decisions, as you can investigate in these ebooks from my organization, GIS for Science, and find some inspiring individuals working in these tools on a daily basis. GIS helps us see things in new ways. GIS helps us not only see what is, but what could be. For example, visualizing new developments. Okay, if we build it with scenario A versus scenario B, what areas of our community are going to be in shadow at certain times of day and certain times of year? This is all made with BIM, CAD, and GIS tools. Or looking at traffic accidents. In the past, what we could do is we could map things like this. We got a lot of data. We could symbolize it by time of day, type of substance involved, etc. But now what we can do with GIS is we could make hex bins, hexagons, and extrude those hexagons in 3D and run spatial statistics on them to see what the hot spots are consecutively for accidents. We want to find what areas of our community are consecutively and consistently severe accident-prone intersections because of our constraints in staff, budget, and time. We can only focus on those, and we're going to focus on those and help improve the lives and the health of the community. That's the kind of thing that we can do with GIS. We can use GIS as a decision-making tool. Now, why do this in Oklahoma? As you are keenly aware, you face hazards, water, climate, and other challenges. You also have a wonderful background and history of educational inquiry. The Oklahoma Alliance for Geography Education, who you will hear from later, your wonderful schools, colleges, and universities. And number 3, your Native American heritage, or the interconnectedness of Earth's systems, the holistic view of planet Earth, and storytelling, which is very much aligned with modern GIS tools and is rooted in ancient ways of storytelling. I would like to show you a few examples of what teaching with GIS looks like. First, the ecological marine units. Not only do we have a 10-kilometer spacing now across all the world's oceans, showing salinity, dissolved oxygen, temperature, etc., But it shows students that the Earth is not just made up of this gray or green or blue expanse of oceans as is depicted on most maps. Indeed, they're dynamic, these oceans, and they affect climate and weather on land and so much more. Secondly, the wayback imagery. Taking a look at 2004 on the left side versus 2023 on the right side. At one glance, you can see, the water's declining in Lake Mead. That's a serious issue. Or changes in right here in Oklahoma City. What has changed in the past 9 years and why? With the same tool, you can analyze coastal erosion, agricultural expansion, ice retreat, deforestation, reforestation, etc. You've got terabytes of satellite imagery at your fingertips in this dynamic environment. The Drought Aware app. With one glance, you see the situation now versus last week versus last month. You can also see the economic impacts of drought. Look at some of these counties in Oklahoma, for example. $19 million in this county alone. Wichita County, Texas. What about this county in Oklahoma? Stevens County, Oklahoma. $44 million in livestock. $1 million in winter wheat potentially impacted by drought. Those are real people, real lives, and real economic impacts. With one glance, that's the power of mapping and these interactive tools. Looking at change over time, looking at an area in Tulsa now, and looking at land cover change with Sentinel-2 satellite imagery. Again, a global data set that you can analyze at your fingertips in a web browser, no sign-in or login or installation of any software required. Students map data in the field. They could map art, graffiti, light poles, tree species, weather, or in this case, litter. I've got some litter mapped here in a downtown area, and I've got these web mapping tools, this online GIS at my fingertips. I'm going to say, I want to map all the paper that I found at these intersections. Okay, now I've got a graduated symbol map of paper. But what if I added all of the types of litter that I found? Now I'm going to get a relationship map. It's going to be a predominant map showing predominance of different types of litter. And if I bump up the size, you'll be able to see it better in the back of the room. If I bump up the size, now, okay, the degree of darkness of each point means the predominance of that litter. Interesting. Now, if I change that to charts and size, I get a pie chart map showing the types of litter and the amount of litter at each spot. And let's just go one more level down. If I say, okay, I want to now make donut rings instead of pie charts, I can do that as well. I can also group these so I see the patterns and the relationships a little bit more clearly. With just a few clicks, I've got a powerful set of tools at my fingertips, as I hope I'm demonstrating here. Now, many educators get into GIS through a series of short 2-page lessons. If you printed this out, this would be 2 pages long, tied to history, geography, economics, biology, etc., standards. In this case, is one of my favorite ones of these several hundred units that we've got online. And each one of these units, like this one on the Dust Bowl, has a series of leading questions that an educator could ask, but they're also, equally importantly, and maybe more importantly, tied to a single interactive web map, like you've seen so far in ArcGIS Online, looking at population 1930. And what about change from 1930 to 1940? Interesting. Let's take a look at that. Okay, so we've got a data table at our fingertips. We've also got these data sets right here, change in population. Now I can really see the decline. Let's pop up a legend, the decline in western Oklahoma, western Texas, western Kansas, southeast Colorado, etc. That's really powerful. And now let's pan over to California. What was going on there in the same decade? Fascinating. So these geo-inquiries help many educators ramp up into geospatial technology. So that's just several, 6 actually, examples. Now, all of these provide teachable moments. For example, can I use that image in my story map? What about location privacy? What apps on my phone are tracking my location and why? And do I need to be concerned about that? Problem solving, framing questions, asking questions, developing a professional portfolio. As students develop these maps and these applications, it becomes part of their professional portfolio. And finally, students as active learners. I hope you're getting a sense that this is active learning here. This whole presentation that I'm giving, again, is a story map. You can see more story maps in this story map gallery on a wide variety of topics, literally from architecture and agriculture to zoology and everything in between, as you can see here. Sounds of the Wild West. It sounds so intriguing, doesn't it? 3 guidelines for all learners, though. Don't stop at the map. Oftentimes people send me their URLs. Hey, Joseph, I've got my data on a map. And I'll say, that's great. And? Why do I say and? Because I want to encourage them to go beyond the map. Take my litter map as an example. Go beyond that. So what? Why is it there? What's where? Why is it there? And why should we care? Why should we care about litter or graffiti or water pollution or anything else that's facing our communities? So think about the bigger issue. That's the goal in teaching with GIS. And also don't get too attached to the tools. You can see here this, some of you may recognize this, an old Mac that is now a doorstop. The tools change, the tools evolve. This is the most important tool to nurture, your spatially enabled thinking brain. So don't get too attached to the technology. And I submit all 3 legs of the geoliteracy stool matter: the content knowledge about hazards, earthquakes, population change, etc. The skills, GIS skills to be sure, but also presentation skills, thinking skills, etc. And the geographic perspective, which transcends disciplines. It's not just in geography. Thinking about career pathways, the GTCM, the Geospatial Technology Competency Model, provides a good way for educators and students to check their progress in aligning their skills to those demanded in the workplace. My Geo Inspirations column was created to help students and others realize that there's a wide variety of jobs in existence that demand spatial thinking skills and that there are many pathways forward. Here are 2 examples of student work with GIS. Here's one on drones with GIS. This student actually mapped the campus with drone imagery for an upcoming event, but also then submitted that to the campus facility people, and the campus facility people actually used that to create a workable, ongoing map of the school, all the infrastructure, the water lines, the electric lines, the campus security cameras, etc. And I like this one that this middle school student made of not only where these right whales were dying in the Gulf of the St. Lawrence, but what I really like, I'm going to skip to the end, is coming up with a solution. Maybe they shouldn't get trapped in these lobster traps, and how can we redesign these lobster traps so that these whales won't be dying in these traps? So that's just 2 examples of student use. In primary and secondary schools, these little red dots, these little red schoolhouses that we have on this particular map, shows you all of the schools that have something called an ArcGIS online organizational account at their school. And that's where they have these technologies available to them at their school. Let's think big here today, though, folks. Let's envision all schools using GIS. What would that take for us to realize that for even Oklahoma? What are the most important skills for students in closing here? First of all, I encourage them to be curious. That leads to tenacity, asking good questions. It's part of the inquiry process. Analyzing data, exploring it, analyzing the information, acting on it, and then repeating leads to new questions. Secondly, being able to work with data. I don't need to tell you folks in the state legislature how big data science is these days. I have a book and blog that's running ongoing that educators can use about where to find data, how do I know if it's any good, how can I assess its quality, and societal issues, copyright, ethics, location privacy, etc. Third, know your geospatial and geotechnical foundations. How do we represent this 3D dynamic planet on maps in 2D and 3D? Be adaptable and flexible. Be willing to go international, or at the very least, outside of your disciplinary comfort zone. GIS is a disruptive technology. It breaks down barriers, helping students think about what they're good at, what they love to do, what the world needs, and what they can be paid for. Fifth, read. This stimulates your curiosity and helps you ask questions. Sixth, and finally, cultivate good communication. Again, maps are wonderful communication tools. I offer 5 recommendations for going forward in my closing moments here. The Thinking Spatially podcast that I run, some of the Our Earth GIS videos, getting a free ArcGIS Online account for your school so you can actually dig into these tools. Seeing is believing, doing is believing. Work through some of these lessons, go through some of those geo inquiries, and finally, in closing, this decade will be exciting for geotechnologies, no doubt about it. You have a key role in achieving this goal for our students and for the future of the state and beyond. Keep the goal in mind that wise decisions will be made with the spatial perspective and the use of geotechnologies for a healthier, happier, and more sustainable future. Thank you.